Oh.
Welcome to 7.1, which is on the Pythagorean Theorem. Most of you have already learned this. This is an 8th grade standard. You learned the Pythagorean Theorem in 8th grade, and so my thought is that you do not need to know what it is. Most of you already know that a squared plus b squared equals c squared. You've done problems before. So how is this going to be different now that you're in Honors Math 2? First and foremost, I don't know if you've ever seen the proof for it. So I want to show you the proof because the proof really, in my opinion, looks cool. So I'm going to scroll over to this, and I want you to watch it. Here's a right triangle. There's 4 of them. That side is C. The y part is c squared. The y part is a squared and b squared. A squared plus b squared equals c squared. It's the same stuff. Let's look at that again. It's going to replay it again. Here's our triangle, a squared, b squared, and c squared. If there's 4 of them, what you would have is this white area called c squared. If you rearrange the 4 triangles, what you have is an a squared on one side, a b squared on the other side, and it's the same area as the c squared area in the middle. One more time. Rearrange it. That c squared distance is the same as the a squared plus the b squared. It's always going to be true. So that brings me to the Pythagorean Theorem. You may or may not have ever seen it proved before, but I like that graphic because it shows you exactly why it will work and it will always work. This says a squared plus b squared equals c squared, but technically you could have b squared plus c squared equals a squared if a is the hypotenuse. It doesn't matter. It doesn't matter these letters A, B, and C. What does matter is that the hypotenuse is what always has to be squared. Does that make sense? The hypotenuse is always the longest side. The other 2 that are being added up are the 2 shorter distances. The 2 shorter distances squared on a right triangle should always equal to the hypotenuse squared. That's what this says. And we can use it to find the third side of any right triangle. Now, what that means for us is that we're going to have to find our answers and put them in reduced radical form. Most of your answers, you're going to have to simplify square roots. What I wrote in our notes is that you're going to have to make sure, if you don't remember how to do that, you're going to need to pull out your notes from 0.2. And so if you need a review on it, that's what I'm reviewing back then. If you still have your notes, they're going to come into play. Most of our answers will be in reduced radical form unless they form a Pythagorean triple, in which the 3 sides are all whole numbers. There are a few Pythagorean triples that we'll use a lot. The first and foremost easiest one is a 3, 4, 5 triangle. Those are nice whole numbers. They're not square roots. 3 squared plus 4 squared will equal 5 squared. It's a Pythagorean triple. There are other common ones which you'll see quite often. Okay. Which takes us to theorems 66, 67, and 68. 66 is the converse of the Pythagorean Theorem. Did you guys use that in 8th grade? I'm not sure. Do you remember doing the converse of the Pythagorean Theorem? Yes or no? Nod your head so I can see. Yeah, no, I don't remember the converse. Okay, so let's introduce it like it's brand new. The converse of the Pythagorean Theorem says if a squared plus b squared equals c squared, then it has to be a right triangle. The Pythagorean theorem says if it's a right triangle, then a squared plus b squared equals c squared. The converse is where you switch those two things, the hypothesis and the conclusion. If a squared plus b squared equals c squared, then it must be a right triangle. That's what Theorem 66 says. Theorem 67 says, if a squared plus b squared is less than c squared, then it must be an obtuse triangle. And Theorem 68 says, if a squared plus b squared is greater than c squared, then it's an acute angle. That it's only a right triangle when it's equal, it's an obtuse triangle when it's less than c squared, and it's an acute triangle when it's greater than c squared. And this picture is really what helps me remember that. If this c squared is a lot bigger than the a squared plus b squared, then it must be obtuse. If this c squared is less than the a squared plus b squared, then it must be acute. And it's only a perfect right triangle when a squared plus b squared equals c squared in that graphic. I'm hoping that makes sense to you. Okay, so that's what we're going to do. So let's do some examples. At this point, your notes are done. If you want, you can go directly to number 4 in your worksheet. Feel free to turn that over in your packet. We are going to do number 4 together. Number 4 has this, and I got to read the directions for number 4. It says, identify the values of A, B, and C, write question mark for unknown values, then find the missing side lengths, leave your answers in simplest radical form. So we have to figure out what's A, what's B, what's C. Generally, for this worksheet, A, B looks like it's a little bit bigger, C is the hypotenuse. Okay? So right off the bat, I already know A is 3. That's one of my answers. I know what C is, but this C is not in simplest radical form. Let's go ahead and review. I'm going to take this C over here. C equals root 45. I do not leave my answer like that. I have to reduce it. If you forgot how to reduce, 5 times 9 is 45. 3 times 3 is 9. And what you're looking for are two factors that multiply, and we can reduce by breaking out any two factors that multiply. I taught you a long time ago, you look for a pair. If you see a pair, you can pop one of those babies out. That there was a second way you could also do it, which is the square root of 5 times the square root of 9. And you know what the square root of 9 is? It is 3. 3 root 5. So now I have 2 of my 3 answers. We do not know what B is. In order to find it, we're going to have to use the Pythagorean Theorem. So, A squared, I'm just going to write it out. A squared plus B squared equals C squared. I know A is 3 squared. I do not know what B is, so I'm going to put B squared equals C squared. And just to make it easier on myself, I'm going to use the original amount, root 45, and I'm going to square that just because it'll be easier. You'll see. Now I'm going to take this. I know what that is. That's 9 plus B squared. When you square root 45 times root 45 is? That's why it's easier. It's much easier doing that than it is 3 root 5 times 3 root 5. You'll still get 45 if you do it, but just wanted to show you. Minus 9. Minus 9. B squared is equal to 45 minus 9 is 36. Is that correct? Then to get it by itself, to get rid of that square, you square root both sides. Technically, this is equal to a positive or a negative, but because we're talking about distances, distances cannot be negative. The math here says that it's going to be plus or minus 6, but we have to eliminate the negative value so we know what b is. B has to equal a positive 6. If you want to check, you can check those answers. 3 squared is 9, 6 squared is 36. Add those together, it's 45, I believe. Yeah. Simple? Now I'm jumping to number 10. Number 10 says, for each pair of numbers, find a third whole number such that the three numbers form a Pythagorean triple. What does that mean? That means that these three numbers, when you add them together, will come out to a perfect. Each number will be a whole number, no radical form. For these problems, like that are in this section, you can basically treat this first number as A and the second number as B. Was there a possibility that it could be C? Yes, but it doesn't work out. So they're just going to be A and B. So what does that mean? We need to find a third number that's a nice whole number. So this is our first step. We're just going to go, okay, 32 squared plus 60 squared should equal some value squared, and we need to figure out what that is. These numbers are quite big. I am going to recommend that you use a calculator, because 32 squared, and for those of you who do not know, let me turn this little light on real quick. Your calculators have a square button on them, 32. This button right there, the x to the 2x squared, we'll put the square right there on that 32. Makes life easier when you use that button. This is 1024. I could do 60 squared in my head. It's 3600. And now I need to add that number and the 1024. So I'm getting 4624 equals c squared equals c squared. And to find out what c is, I would need to square root whatever that answer is, which is what my calculator helps me figure out. C has to be 68. Is that a nice whole number? Then it is a Pythagorean triple. Okay? That's what that is. Pythagorean triples means that this is a whole number, this is a whole number, this is a whole number. No decimals, no radical form with triples. Turn that light off. Last example, and then I think you'll be ready to roll. The lengths, we're going to jump to number 16. The lengths of the sides of the triangle are given. Classify each triangle as acute, right, or obtuse. 7 root 3, 14. Don't know. Is it acute, is it right, or is it obtuse? The first thing you need to figure out, which one is your longest value. Is 14 the longest, or 7 root 3 the longest? If you're not sure, take your calculator and type in 7 root 3 and figure out what is that as a decimal. Switch it to a decimal. Figure out what is 7 root 3. It's about 12.1. Which one's longer? Now you know. Now you know that this has to be the C, and this is the A, and this is the B. Now we don't know if it's acute, right, or obtuse until we perform the Pythagorean theorem, or one of the theorems right behind it, 67, 68, whatever they are. So what I like to do is I like to set it up like this. A squared plus B squared. And I put a little box like this. Like, I don't know. Is it equal to it? Is it less than? Is it greater than? Because I don't really know what's going to go in that box, but I'm going to figure it out. So I put in 7 squared plus, in parentheses, 7 root 3 squared. And then, here's my box. And c squared, I'm going to put 14 squared. This is where my calculator comes in. I don't know my 14s. 14 squared is 196. I'm going to put that right there. I know what 7 squared is, 49. And 7 root 3 squared in parentheses means you're multiplying the 7 root 3 times another 7 root 3. It's going to be 49 times 3. But you can punch that whole thing into your calculator if you want to. 7 root 3 in parentheses, root 3 squared, making sure my parentheses is outside that radical. It'll take the 7 times 7, it'll take the root 3 times the root 3 and multiply that, which is 147, which is 49 times 3, same thing. If you wanted to, you can take that and add 49 to it. And guess what I get? I get, oh no, Mr. Bramo. Oh no. 196 and 196. And now I'm hoping you can see what goes in that box. Go ahead and say it out loud. What goes in the box? And what does that mean? Very good. I hope that helps you on your notes for 7.1.